Today we're going to look at angle measurements in degrees and how they kind of fit in with a coordinate plane. So first of all, definition of an angle. It's determined by rotating a ray. Remember from geometry, a ray is a line that has a starting point but no ending point around a point. There's two different ways to rotate this ray. One is in the positive or counterclockwise direction, which is the diagram that I have for you here. And then the other is in a negative or a clockwise position, and I'll show you that in one of our examples. A little bit of vocab. Each angle now, instead of just being two rays meeting at a point, there is an initial side, the ray that is kind of that starting point, and then the terminal side, which is where it gets rotated to. Coterminal are two angles that share the same initial and terminal side. You might think those are the exact same angle, but when you are rotating a ray around a point, you can rotate it more than a full circle. So they can end up being different angle measurements, but still looking the same. All of our angles will be drawn in what's called standard position. And this is when the initial side of the angle is on kind of that positive x-axis, and then the terminal side will land somewhere on the coordinate plane. As a reminder, hopefully you remember your quadrants. The first quadrant is the positive quadrant, and then we rotate counterclockwise to quadrant 2, 3, and 4. And as we rotate, we would get a 90-degree angle if the terminal side was on the positive y-axis. Of course, 180 degrees is half a circle, 270, and then a full rotation would be 360 degrees. First thing we're going to do is learn how to sketch angles on a coordinate plane. So a 75-degree angle, first of all, we will start with our initial ray on the positive x-axis, standard position. 75 degrees doesn't quite make it up to 90 degrees, it's just shy. So we are estimating here, we are not getting out our protractors and measuring precisely. Again, starting with our initial ray in standard position on the positive x-axis, 120 degrees is 30 degrees past 90, so it would land in the second quadrant. Now we're going to learn how to sketch angles that are rotated in a negative direction. Again, starting off with that initial ray in standard position, and this time we are rotating counterclockwise. Negative 170 degrees goes not quite to the 180, so this angle would land in the third quadrant. And negative 400 degrees, starting with our angle in standard position. This time, again, we're rotating clockwise. A full rotation would get us to 360 degrees, so we would go 40 degrees more. When you are rotating your angles, especially when it's more than 360 degrees, more than a full rotation, draw that kind of swirl or loop that I have in the center to demonstrate to the reader of your work that this angle is more than 360 degrees. All right, this should be a quick refresher of complementary and supplementary angles. As a reminder, complementary angles add to 90 degrees, and supplementary angles add to 180 degrees. So when we're finding the complement for a 57-degree angle, we would take 90 and subtract the 57 degrees, which would give us a result of 33 degrees. To get the supplementary angle, we would take 180 degrees and subtract the 57 degrees, which would give us a result of 123 degrees. All right, now we're going to learn about coterminal angles, and I'm going to sketch the two angles on the same coordinate plane. So first of all, our 60 degrees in standard position would look roughly like this. So to get a coterminal positive angle of rotation, we would add 360 degrees, which would give us a total of 420 degrees. On the coordinate plane, we would still have that initial side on the positive x-axis, but this time we would rotate all the way around and back up to that 60 degrees. For a negative coterminal angle, I would subtract 360 degrees which would give me an angle of negative 300 degrees. As a reminder, notice I am labeling all of my degrees with the degree symbol. Sketching this angle, starting in standard position, this time we are rotating clockwise, and we would still land with that same terminal side. For our negative 30-degree angle, starting off in standard position, we would rotate clockwise into the fourth quadrant. For a positive coterminal angle, I'm going to add 360 degrees, which would give me a 330-degree angle. Same initial side, rotating in the positive or counterclockwise direction to land at the same terminal side. To get a negative coterminal angle, we're going to start with the negative 30 degrees and subtract 360, which would give us negative 390 degrees. On our graph, same initial side, rotating, continuing in that negative direction all the way around back to the terminal side. Here are your two U-Try questions. Please try them out and bring your questions to class.